Inside a nuclear power plant, something invisible is happening. No fire, no smoke, no burning fuel, and yet massive amounts of energy are being created. Turbines begin to spin. Electricity flows out of the plant, powering entire cities, thousands of homes, all from something too small to see. An atom, deep inside the reactor, atoms are being split apart, releasing enormous heat. But from the outside, everything looks calm. Silent towers, steady systems, controlled machines. So how does splitting an atom create electricity? How does this invisible process power the modern world? To understand this, we must go back to the very beginning, inside the heart of the nuclear reactor. At the center of the reactor lies the fuel, small cylindrical pellets, made from uranium. Each pellet holds a surprising amount of energy. These pellets are stacked inside long metal tubes, called fuel rods. Hundreds of fuel rods are grouped together, forming the reactor core. Inside this core, the reaction begins. Uranium atoms split. One atom becomes two, releasing heat and more particles. These particles strike other atoms, creating a chain reaction. If uncontrolled, this reaction would grow rapidly, so the system must stay stable. This is where control rods are used. Long rods made from special materials. They absorb extra particles, slowing down the reaction. By moving these rods up or down, the reactor stays balanced. Not too fast, not too slow, a controlled release of energy. The reactor is now producing heat, but heat alone is not electricity. This heat must be converted. Inside the reactor, water flows around the fuel rods. The temperature rises quickly. The water absorbs this heat, but it does not boil immediately. It stays under high pressure, hot pressurized, controlled. This hot water now moves into a heat exchanger, a separate system. Here the heat is transferred without mixing the water. Clean water on the other side begins to boil. Steam is created, high-pressure steam. This steam is directed toward massive turbines. The energy is now ready to move. From invisible atoms to powerful motion, the steam is ready. Now the energy begins to move. High-pressure steam rushes into massive turbines. The force is powerful. The turbine blades begin to spin. Faster and faster. This spinning motion is the key. The turbine is connected to a generator. As the turbine rotates, the generator turns. Inside the generator, magnets move around coils of wire. This motion creates electricity, a continuous flow of energy. From heat to motion to electricity, the system runs smoothly, controlled, stable, efficient. The steam loses energy as it passes through the turbine. It begins to cool, and the cycle continues. Inside the plant, electricity is now being produced. The steam has done its job. The turbines have turned. Electricity has been created. But the cycle is not finished. The used steam must now be cooled. Inside the plant, the steam enters a condenser. Here, cold water flows through large tubes. The steam touches these tubes. Slowly, it begins to cool and turn back into liquid water. This water is collected and sent back into the system. The cycle begins again. Outside the plant, tall cooling towers release white clouds into the sky. These are not smoke, only water vapor, heat leaving the system. Inside the plant, everything continues in a loop. Heat, steam, motion, electricity, a continuous cycle of energy. The energy is now ready. Electricity leaves the power plant through massive transmission lines, high above the ground, traveling across long distances, from the plant to cities, to homes, to industries. Transformers adjust the voltage, making the power safe and usable. Lights turn on, machines begin to run. Entire cities come alive, all powered by a process that cannot be seen. Deep inside the reactor, atoms continue to split, quietly, controlled, producing energy every second. A single nuclear power plant can supply electricity to millions of people. Without smoke, without burning fuel, just the power hidden inside atoms. From the smallest particles to the largest systems, this is how nuclear energy powers the modern world.